All right, guys. Super excited to have both you guys here. I think you guys both have some really unique perspectives on transitioning into data science. We got Vin coming from the engineering background and Leonard coming from the academic background. So, Leonard, let's start with you. Talk to us about your experience transitioning from academia into data science industry.
Great. Yeah, thank you so much for having me. So I had moved out to the Bay Area 15 years ago to pursue my PhD in biomedical informatics. And I quickly realized that for a poor grad student, it wasn't always easy paying the rent in pricey San Francisco. And I thought to myself, well, for my academic work, I'm basically trying to squeeze the signal out of data, and I make a paltry grad school stipend out of it. Can I expand these skills to actually get an extra stream of income? And I wound up starting my own data science consultancy on the side, which initially just entailed me cold emailing local startups and going, hey, do you have any data that you need analyzed? And most of the time they would just ignore my emails. Sometimes they would say yes, and I got to expose myself to a broad array of projects. But more importantly, I was able to establish connections in the Bay Area entrepreneurial community. This eventually led me to joining the founding team of a startup called Primer, which focused on natural language processing and text analytics. And I was in charge of building out Primer's foundational algorithms. And kind of in this way, I completed a transition from part-time academic and part-time data science to doing industry data science development full-time.
That's an interesting transition, going from sequencing DNA and genetics into natural language processing. Was that quite a chasm to cross in terms of the skills and knowledge required, or was there a bit of overlap between the two?
It's not as a surprising transition as you might think. So as a researcher, I would analyze sequences, DNA sequences and protein sequences. So basically letters like A, T's, C's, and G's representing nucleic acids and amino acids. As eventually, as I began to transition into natural language processing, I would analyze a sequence of words making up sentences, which is a very different task, but is quite analogous to what I had done as a researcher. In fact, in many of the same algorithms could be applied to that task, and it was much easier to validate my results, because if I wanted to know if my algorithm was working, I could just read the output instead of spending 6 months in the lab. And that's a point that I want to emphasize. A lot of these techniques overlap across seemingly different problems because those problems aren't as different as they may initially seem in the first pass.
Vin, talk to us about your experience transitioning into data science. I know you come from a really, really strong software engineering background. What was that transition like for you?
I got lucky because when I was transitioning into the field didn't really have a whole lot of definition, and so all the little missteps and things that I did when I was first starting out was sort of covered up by the fact that everybody was making the same mistakes. So I was able to, for a lot of clients that I had, define what data science was and take them from BI and analytics, which was a lot of the work that I'd been doing for about 3-4 years at that point, and take them into data science and eventually machine learning, start looking at it from an engineer's perspective, which is we've got to deploy something, it's got to go to production, it's got to be worth cash, you have to make money off of this. And that's really how I got into data science, is focusing on value, focusing on products and building cost savings and revenue. And like I said, it was an interesting transition because I was at the point in my career where I was trying to get into product management. And so instead of becoming a product manager, I really became a data scientist, but I still brought a lot of the strategy to the job that I did. And I learned a whole lot more about data science by having this sort of hybrid where I had the software engineering and the software dev background and that whole software development lifecycle. I'd spent over 10 years in that every day. Also really close, like I said, for that last 4 years before I made the transition, really close in with the data, the analytics, BI, and doing some more advanced work on customers, understanding even a little bit of supply chain. And then having this focus on strategy all just kind of come together, and there I was in data science, and that's what the field became. And like I said, I got lucky because that transition, most people have to make it all at once in order to land that first job, but my first clients were figuring it out just as much as I was. And so it was an interesting way in, and like I said, I was a little bit more fortunate than most people.
And for myself, my transition to data science was coming from a biostatistics background. So I'd worked for 5 years as a biostatistician, clinical trial statistician, just essentially writing up statistical analysis plans, designing experiments, and doing things like that. Prior to that, I was working as an actuary. So I had, and then prior to that, I was a grad student in statistics and math. So I had like a strong foundational background in the stats and probability, but precisely zero skills when it came to software engineering or coding or anything like that. A lot of the programming I had done up until that point was mostly in SAS or R, and that was it. Like writing software was not something that I'd ever done, and that was the biggest obstacle for me to overcome, was learning how to write decent software. But one thing that's interesting here is both of you guys had kind of a really resounding theme, was the fact that you took things from your prior work experience, some certain skill sets or principles, and applied them in this new kind of domain, in this new realm. Talk to us about how your non-data science experience has set you up for success in data science. Let's start with Leonard, and then we'll go into Vin.
I like to use a chess analogy. I like to think of these transitions as the knight moves. So a knight moves vertically, and then it radically moves to the right. So in this way, given the vertical skills that I have, what is the sort of rightward transition that I can make to leverage them, to leverage these skills in a space that I haven't quite leveraged yet? And actually, even before I transitioned into natural language processing, I wound up doing a lot of consulting in the health insurance space, even though I knew nothing about health insurance to start with. Two reasons. A, as somebody that had a biology degree, it was just easier for me to get my foot in the door. B, I quickly realized that the healthcare insurance codes are also not that different from DNA sequences or sequences of words, just like sequence of insurance procedures carried out on a patient and so forth. And so I just found this rich opportunity to apply the knowledge that I already have, which was just boring years-old knowledge in the bioinformatics space, to a space where this hasn't really been tried before, and it worked, and that was really an exhilarating, experience. The other point I want to make is once I made this discovery, I started, hitting up all the health insurance companies, and a bunch of them really wanted my insight. So, I guess one way to think about this is, given the skills that I have now, where are those skills underused? And that's a hard problem to answer, because they're probably underused in a space that you're not that familiar with. But if you do your research and you're basically brave enough to actually try and expand your knowledge in that space, you have a relatively good, chance of making the transition if kind of like those skills and mindset are actually relevant to that new space.
Vin, same question to you. How has your non-data science experience set you up for success in data science?
I'm actually going to go back even before I got into technology. I sold stuff. I was in sales. And I think one of the core success factors for what I do now is I can sell. And I'm not afraid to ask for business. And I'm not afraid to talk about the benefits of what it is that I do and what I can bring to a business. I think that, even something that's outside of tech, bringing that skill from your prior career is huge, because think about it. The things most data scientists don't have are the things most data scientists don't learn. And so if you've never been in sales, you've never had to close someone. You've never had to ask for business. And so that's, if anyone's trying to break into the field right now from something, even if it's completely outside of the field, even a tangent that doesn't make any sense as a night move, it's more like a knight drunkenly stumbling into a field. Even if it feels that way, you can still bring a whole lot of skills from non-technical fields and non-technical roles into your technical work as a data scientist. You can bring a whole lot of non-science skills into the science side of what it is that you do. Because when I talk about strategy, the amazing thing about research and strategy is the C-suite has been sold this concept of strategy planning by digital transformation evangelists and everyone else, but they don't have like that slide 2 where they say, here's this amazing thing, blank slide 2, and then profit. But if you do research, you have slide 2. And that's huge. And being able to sell that, being able to talk to the C-suite and explain, look, I do research. So all those questions you have where you say, I want to do data-driven strategy, I'm not just going to make it up with a dashboard. I'm going to come in here and do some research and explain this dashboard to you in a way that you've never had one explained to you before. We do research here. And it's all of those skills that you bring, and then evolving it towards what a data scientist does. And not just doing data science, but making yourself better as a data scientist by taking those skills and bringing them to a field that doesn't have a lot of them. And I think that's the most important thing for people to remember is I brought skills from outside of data science. You can too. I brought skills to writing code from outside of a technical role, and you can too. And just remember that no matter what it is that you're doing, look at these big transferable skills, things like communications, leadership, any sort of strategic roles that you've held are huge. Anything that's product focused or customer centric, those are huge because those are things you don't get taught in most data science curriculums. So I think the biggest opportunity in data science is for people coming in from outside of the field.
Yeah, definitely. Because if you're coming in from outside the field, you've got a different perspective. And what does that different perspective allow you to do? Hopefully, you've seen a wide variety of problem statements in your past working life. You are able to match a strategy to a problem type to work yourself up to a solution. But also that point about selling, man, yeah, you got to learn to build, learn to sell. If you could do both, you will be unstoppable. And one thing that really stuck out to me that I really liked, because it's something I firmly believe in, is that there's not like one skill that's called data science, right? Data science is a broad umbrella category. I'd even argue that you can't even learn data science, right? It can be, you can't teach data science, but it can be learned through experience. But it being a broad umbrella category, to me, data science, it's not just the classical data scientist, data analyst, business intelligence, data engineering, machine learning engineering. All of these roles are part of the data science family. So when we are transitioning from a career that's outside of this type of data science family, how do we identify which path it is that we want to take? We'll start with Leonard on this one.
Again, before I was a data scientist, I was a scientist, and in the data science space, broadly the same aspect drives me as what drove me in the science space, which is curiosity. I was curiously drawn to certain very hard problems, hard open-ended problems, and my curiosity forced me, made me obsess about finding an interesting solution. So before as you consider, obviously you need to consider what's best for you career-wise, but the best way, I firmly recommend that if you want to, put your foot into those, put your toe into those warm waters, ask yourself, what am I curious about? Well, what sort of data patterns am I curious about? Maybe the spreading diseases, patterns in Twitter, fluctuations in social media, and once if you feel that internal curiosity percolate up, take the next step. Create a project, a side project. Go explore something, analyze something, ask some hypotheses. How do tweets pertaining to pandemic relate to the world economy or whatnot? Very broad and open-ended question. You're probably not going to be able to answer it, but if you're curious, then try. And then the next step is to see what tools are out there and what tools do you enjoy using? Do you like building ML tools to try and make predictions? Are you more into, visualization and exploration of the visualization data and building cool dashboards for others to use? And you can use that to guide your interests. And in that manner, that side project can provide you with very valuable skills to make your transition, and B, also outline what sort of aspects of a data science career interest you the most. I really recommend it.
So Vin, let's do like a little bit of role playing here with an imaginary profile. Let's say there's somebody who's maybe worked for 3 to 4 years as a software developer or a software engineer at some type of a, let's just say a startup company where they're building apps and whatnot. If they want to make that transition into data science, what are some paths that you think might make that transition a little bit easier for them?
Well, think about the user. This is what I always kind of come back to. No matter what field you're in, you have users. And if you want to understand those users better or serve those users better, you can do that in data science. And if that's kind of your passion, that's a great way to go. Why was it that you loved developing apps? I mean, if you hated it, sorry, I can't help. But if you enjoyed what you did before and you're just looking to do more, what was it about the customers that you loved? What was it about the product that you built that you loved? And how do you translate that passion into questions that someone in data science may be able to solve and may be able to give you deeper insights about? And for me, it was the customer. That's where I went. I was developing software, but I was so customer centric, again, because of a prior role that I had where I was literally face to face with the customer. And I got passionate about understanding customers and understanding why people bought anything, software, products, doesn't matter. I got really passionate about figuring out how customers think and how people think. And that led me down the behavioral path. And that walked me right into data science and machine learning. Do the same thing. If you're a software developer working on apps, again, find that passion and then ask yourself, how could I use data to sort of continue my path towards this passion type project? And that's really where Leonard was going. He was, start with that passion, start with that spark. What is the curiosity and why are you curious about it? And I think that's, once you have that as your target, you can specialize. Then you decide, okay, what tools am I passionate about using? Am I passionate about the software side of it? Have I started playing around with actually doing research and gotten really into the research side of it? Am I more on the data engineering and data ops? Do I like building pipelines? Do I like the hands-on piece of it? Is there, complex problem sets that I want to solve? Do I want to work on building tools and platforms for a company? Is that what you're passionate about? And it's kind of this two-sided decision that you have to make. Number one, what problems are you passionate about solving? And then number two, what types of approaches and tools are you passionate about using to solve those problems? And remember that data science it's massive, it's growing, it's not one role anymore. Like you said, it's this entire spectrum of roles. And different companies have different opportunities for you. If you're at a startup now, you're probably used to being I am everything. And sometimes I'm developing apps, sometimes a QA engineer. Every once in a while, I'm a sales engineer. And you're used to having a lot of hats on your head, for better or for worse. Maybe you like that. Maybe you like being, sort of the problem solver and somebody they can rely on. That tells you what kind of company you want to work in and what kind of role you want to focus on landing. Whereas if you're in a larger company and you like just being heads down, big team, everybody working together to solve a problem, then that's where you want to go as far as the company and the business focus. So, narrow it down as much as you can so that the roles you apply for and the education that you decide to take on is going to be as useful and as valuable for you and your potential employer as possible.
Yeah, thank you very much for that, Vin. That's a hard thing to do, to try to find your passion in data science. And I think you definitely share some valuable tips there. Leonard, how did you find your passion in data science?
So again, to reiterate what I said earlier, my passion is problem solving, hard, open-ended problem solving, and that usually pertains to a space that hasn't been fully explored before. So if I had to pick one particular passion, it's hard. I would have to honestly though, like the type of project. I mean, I enjoy working on a variety of projects, but I particularly enjoy, the nexus of data science and the startup space, doing not just analysis, but using that analysis to help build a company from the ground up. And I guess the reason I enjoy that so much is because the fruits of my work, the fruits of the analysis, get transformed into some sort of tool or product that other people can use, that other individuals can use, and it's very satisfying to to see what you've analyzed, what you've built, actually get deployed and be used in the community. I mean, it's one thing as an academic to write a paper and get one or two citations. It's another thing to see individuals, whether customers or users, engage with a product that's driven by the analytical insights that you've created, that's driven by the machine learning models that you've trained and deployed. And honestly, if I weren't in the startup space right now, I would probably be trying to get some sort of data-driven open source project off the ground, because that's what I enjoy the open-ended problem solving, but the real cherry on top of my data science sundae is user engagement.
Yeah, there's an element in there of just know yourself, know what it is that you actually want to work on, and then narrow down the organizations, the industry, the teams that you go interview for, to make sure there is some proper alignment between what it is that brings you joy and happiness as an individual and what this role is offering. Like me personally, I absolutely love going deep into problems, like just like you, Leonard. I love problem solving, but not necessarily having to build out the entire technical solution in a rush. Like, to me, that's not that much fun. I like going heads down deep into the research and trying to find the optimal path forward. So to me, that led me towards more data science roles that were research, oriented. Got a question here from Chris Ogrebeck. It's very relevant to what we're talking about here, and I'll have Vin answer this one. We're talking about data science being a huge field, right? How do we find the right subfield? Is it a matter of looking to seeing what particular topic is a new hot biggest things? Are there evergreen subfields that you recommend getting into? What would you say to someone who's like, I've got this set of skills and I want to do something?
What I would say is skate towards the field. And that doesn't mean chase trends. That means look at about a year to 2 years out. What's being worked on right now at sort of your top tech companies, at your early adopters of machine learning? What are they working on? What research are they publishing? And think that most of the common themes, the big central themes to the research and the open source projects that they're publishing, are going to be things that more and more companies are going to adopt in about 2 years. And so that's really, if you're 18 months away from getting into the field, if you're 24 months away from getting into the field, you want to be looking at learning about not what people are doing right now, but how what's being built will change that and what they'll be doing in 18 to 24 months. I mean, think about it. If you'd have been ahead of the curve on ML engineering or data engineering or on the applied research side, you'd be in great shape right now. And 18 months ago, that wasn't such a huge focus. It was just starting to bubble to the surface, and we were starting to see the tech stacks to support that becoming more prominent. But if you had been, looking at the 2018, 2019 data scientist, where would your career be right now? And so when you look at the field, really look at, number one, where it's going. So understand that as far with respect to your time horizon for breaking into the field. And second, what do you like to do? Because ML product manager is going to be an emerging role that's going to be huge. Do you like the strategy side? Maybe you're not so much on the building side, but you like touching the customers, you like touching the strategy, multiple parts of the organization, leading without authority. I mean, if all of those sound enjoyable to you, and you still want your hand on ML products, that might be the right way for you to go. Put your head into what these people do. And that's not only just looking at job descriptions, but talking to people who do it now. What does model quality mean? What does model maintenance when it comes to ML ops mean? What does it mean for you to build a data pipeline? How about data sourcing? Think about all these emerging roles that are coming up. And like I said, put yourself in that role. Do a little bit of role play for a little bit. Figure out what these people do. Talk to people in the field and think about it. I mean, do you really want to be doing this for 5, 6, 7 years? But at the same time, also realize that in 5, 6, 7 years, machine learning will look totally different. And so you'll be continually learning and reskilling and moving on, like I said, skating to where the field is going. So also think about that when you get into data science. You're never going to stop learning. And that's something some people can't get their heads wrapped around, and some people don't enjoy that. And so if you like a more static field, this is probably not the right one for you. But if you like something that's continually evolving, going to continually offer you opportunities and challenges, this is a great field.
That's my favorite part about data science is the older I get in the field, the more I realize just how little I know. And it's just this desire of just wanting to learn more, and not even curiosity, I would say wonder. It's the sense of wonder that propels me to want to continue to learn more and more. I spend 2 hours of my day reading just to learn, and just because I enjoy it so much. So you have to have that lifelong learner mentality to really excel in this field. So I've got a question here from Chithresh Kumar. He's asking, how should we prepare for data science entry-level role after a master's degree in data science? And I'm going to say my short answer to that is going to be do a project, right? It's one thing to have a knowledge base, but you have to do something with that. So you must apply it, and you need to apply that. I mean, hopefully during that master's program, you got an opportunity to do internships, but not everybody gets that opportunity. You can make an internship for yourself by creating a project, a well thought out project. So Leonard, as a hiring manager, when you got a stack of resumes that you're looking through, first of all, let's first talk about what type of profile you look for in these resumes for a transitioner, and then what do you look for in a project?
Mm-hmm. Okay, so first and foremost, depending on the role, I very much do look for individuals that are making that transition, because a quality senior data scientist is hard to come by. But in my experience, if you pick out the right person making the transition and you mentor them through their transition, then they become, a year or a couple of years out, they become an invaluable senior employee. So I specifically look for transitioners from both the academic and the engineering space. Now, when examining the project, I look first and foremost, I look for open-endedness, an open-ended problem that this individual tried to tackle. So, no Udacity filled by the numbers course. It's respectable that you did that, but that's not what I'm looking for. I want to see you try and gather open-ended data and do something interesting with it. One time, I clicked on a candidate's GitHub page and saw a project to crawl horse racing data and try to predict, which horses would win with references to papers and references to mathematical techniques. The candidate had not even listed it on their resume, but I was very much impressed, and he had a great time discussing with the candidate during the interview because they were so engaged with that work. The second thing I look for is code quality. Yeah, it's great that if your project works and all, but it's very important for me as a hiring manager to know that you have those clean engineering skills, to know that your code is not spaghetti code, that you thought about, structure and quality and readability and comments. And it's something that I highly value. So when your project is ready to be presented to the world publicly via a GitHub page, be sure to clean up your code to the best of industry standards, because for someone like me, that is very important.
It's definitely important for someone like me as well, because if you think about it, if a hiring manager or potential future teammate is going to be looking at your code, you want them to look at your code and be like, oh my God, like I want to work with this person. Like look how easy they're gonna make my life when they're part of my team. Whereas if you just submit a notebook with spaghetti code, I'm like, oh my God, I can't work with this guy. And it's really easy to do just follow some frameworks. There's cookie cutter data science. That's one thing you guys could take a look into. Kedro is also a amazing framework that you can look into. So those are definitely tools available to you. Vin, what is it that you look for in a project?
When it comes to independent project work, I want to see a business case. Like I want to see a why behind what you did. And if you don't start with a why, immediately I know that there's a lot that I'm going to have to teach you. Even beyond coding. I mean, yeah, definitely. Best practices, don't let your GitHub repo look like garbage. Don't have 8 abandoned projects showing, and all the little things that can kind of turn into red flags. Definitely be clean and concise. But at the same time, I mean, why'd you do this? What was the point? Why did you do this project? That's huge. And if you have a business case, if you restate the business problem, and if you start tying, this is what my model is going to do, I suppose, to fix or address or improve or have some sort of business value. If you do that closed loop at the very beginning, and it's usually a 1 or 2 page write-up. I mean, I'm not looking for a full formal business case. You're not starting a business. I don't want an MVP. If you do one, awesome. But give me the business case. Let me understand why you did this project, and then make it real world. Like, don't do toy data sets that are clean, and just don't do that, because that's not my life. I've never gotten clean data before in my entire life, and should I live such a charmed life? So that's the next piece. Is this real? Is this a real world scenario that you put yourself in? Because that tells me you may not have ever done this before at a business, but you're ready to. You're ready to go into a business and solve business problems. You understand that concept and you understand the challenges, everything from data to, maybe you don't have enough resources. Doing a feasibility study, saying, here's my business case and here's what I got. Like, here's the data that I went out and found. Here's the resources that I have available to develop. Can I actually do this? And, you can have an entire project where you just kill it. And that shows a level of maturity for you to say, look, I think I could have done this, but I look at it from a feasibility standpoint and I just, we can't do it. And so a lot of my answer really is just realism. Bring realism to your projects and understand that in a business, it's different than in academia. So be real world and be pragmatic.
Absolutely love that. So we've got a lot of good questions funneling in through the chat. So let's wrap it up with the last 4. Yeah, definitely. So let's keep this going actually. Before we jump into some questions from the chat. So let's talk about we talked a bit about picking which direction to go into, and there's some elements in there about specializing versus generalizing. How can we make the case for one or the other, and how do we decide which one is going to be right for us? Leonard?
Yes. So, from my standpoint, even if you specialize, you have to be a bit of a generalist, because open-ended problems are world problems are messy, and there's never really one solution, and you have to kind of generally be aware of the various solutions that are out there. Having said that, like, if there's an area that you're particularly passionate about, imaging data, or an area of business, or like you're fascinated by self-driving cars and that space, or like self-flying drones, well, that automatically limits the types of skills that you'll need. Machine learning, maybe some robotics, some imaging processing. That already limits the space. Do you want to work at a startup, or do you want to go into more business analysis? Like, where do your passions drive you? I think by asking these common sense questions, by playing 20 questions with your passions, you're automatically gonna scratch out certain skills that are less relevant to what you want to do, and percolate up skills that are absolutely necessary to breaking into that space. So that's how I would go about doing it.
Vin, what do you think?
I think you have to find a niche. because, when you go generalist, you're going to have way more opportunities, but your career is going to be fairly short. And so if you want to go deep, if you want to have a lengthy career in the field and not consistently be chasing new tools and new methodologies and new approaches, you have to find an area that's small enough that you can learn very, very deeply in that in that area. Having said that, being a data scientist means a lot of different things. And if you work at a startup, you're going to need to be deep in a lot of different directions. The startups that I've worked for, I've done some non-data science roles as a data scientist just because that's the necessity of it. If you're in a larger company, you're going to be able to be more focused and more directed towards your particular field or your particular niche. So I would say, the startup is always the asterisk, because in a startup, you're going to have a whole lot more to do. But in a larger company, your role is going to be better defined if they have a mature data science team. If they don't, they're more like a startup, to be honest. But, in a larger company, you're going to have more of a niche role, and you're not going to be doing as many of the tangential types of activities that you may find yourself doing elsewhere. So I would say, unless you're in one of those edge cases where you're going to a company where they need a jack of all trades with depth in one area, I would say niche as much as possible, but also realize that some of us kind of like being able to do a ton of different stuff. I love being able to, from the strategy side, build a product strategy, create the roadmap, and then I take one project from cradle to grave. And that's amazing. I get to flex every single muscle that I have as a data scientist, as a strategist, and that's amazing. That's fun for me. But it also means I sacrifice some depth when it comes to research. I don't understand all problem spaces as well as I could if all I ever had to read about was data science. So there's trade-offs there, and you have to be aware of that.
Yeah. So I think of it this way, like, mine's a bit of a contrarian point of view from you two there. I'm a huge fan of generalizing, but then specializing on demand, because it is incredibly hard to be top 1% in one particular problem statement or one particular domain. But if you're able to combine skills and stack skills, and maybe in skill 1, you're top 25%, skill 2, you're top 25%, skill 3, you're top 25%, then when those skills intersect, you can be top 1% in that intersection, right? So that's kind of my philosophy of it. Like, definitely learn the fundamentals, learn the basics, but get good enough in a wide number of areas, and then actively look for those intersections, and then you will become the best in the world at those intersections. I'm just curious what you guys think about that when it comes to combining skills in this field. Leonard?
I am in 100% agreement. I think my whole career, even before data science, revolved around niche opportunities at two intersections of skills. As an undergrad, I studied biology and computer science because I know lots of biologists and lots of computer scientists, but not that many at that particular time. Not that many people are focused on that niche. Of course, it's very different now. Then, as I started out my career, I began to kind of like see if I, expand that space. Well, if I can look at sequences, maybe I can do more with natural language processing. And this is before natural language processing was, as hot as it is now. I'm also, I'm a firm believer in picking up these little side projects that are tangentially related to the main project, where the problem space might be slightly different, and to find the gaps in my current knowledge and problem solving abilities, fill in those gaps, and then again I have a stacked skill. I totally agree with what you're saying. I think you have to be smart about it, like a type of breadth first search. You have to probe the neighboring you have to probe projects and skill sets that neighbor what you already know, and try to expand outwards. But I think it's invaluable to have that flexibility. Very valuable.
Vin, any comments here?
Yeah, I think we have the luxury of seniority because I'm old. I won't speak for everyone here. but I'm old. I've been doing this forever, so I have this ridiculous breadth. I mean, when they started talking about unicorns and they said there was no such thing as unicorns, there are a bunch of us that are old, having more gray hair than sometimes common sense. But we're unicorns because we've been here forever. I mean, you just start picking up a lot of different skills. You just start picking up a lot of different capabilities. I've forgotten more programming languages than I think I'm proficient in now. And that's the luxury of seniority, is I can say, well, yeah, get this big breadth. But if you're somebody trying to break into the field, if you're in the first, say, 5 years of your career, or minus 2 years of your career trying to learn and get ready for it, you don't have the same luxury of seniority that the rest of us do. And so when we talk about diversifying skills, yes, long-term, awesome. Definitely have this broad skill set, because you see, for my resume, I get to bring the whole thing to bear, and it's awesome, and I get to work on some really cool projects. But in your first 5 years, I mean, find that niche that'll get you that first role and get really good at it and get new projects and get more opportunities. And your skill set's just going to grow naturally. It'll grow organically at the rate of your curiosity and your mindset. And so you can quickly become broad. But when I say quickly, we're talking about 10, 15 years. And then you'll get to the point where you look at your career as, I get opportunities because I can take on complex, multidimensional projects. And I can learn very, very quickly because I've seen the patterns that underlie engineering. I've seen the patterns that underlie research. I've seen the patterns that underlie the strategy side of this. And now everything's a variation on a theme and bringing new, more effective tools to bear on problems. And I build on this body of knowledge now. But at the very beginning, I would say really specialized niche, get into the field because you're really good at a certain number of roles. And it's almost impossible to deny your value and not hire you.
Yeah, absolutely love that. I mean, get into data science, you got to realize it's going to be a long lifetime of learning, of creating, of doing, and exploring, which I think is just a beautiful thing. So let's talk about this then. Let's say there's somebody who is transitioning completely from a field that's unrelated. Let's say somebody from sales is like, all right, I want to get into data science, right? If we had to distill down the fundamentals, first principles that any data scientist should know at a bare minimum, I know it's a huge order to say that, but what would you say are some of the things that are absolutely fundamental that a data scientist should know, so that if somebody is transitioning from something completely unrelated, these are going to be the skills they need to absolutely go pick up? Let's start with Leonard.
I'm going to keep it overly very broad because obviously there's a lot you need to know. But just going to briefly mention coding. I think that goes without saying. You need to be a coder. A skill that I want to emphasize that I don't believe is not being emphasized enough is comfort with uncertainty, comfort with open-ended problem solving. I met many talented individuals that, let's say, have picked up engineering from scratch and are able to, build an app server over the course of 3 months where they know exactly what steps follows, each subsequent step. Data science is not like that. There is uncertainty, but it's uncertainty that can be managed. It's probabilistic. It's kind of like poker, where you're not guaranteed to win every hand, but if you're comfortable with those uncertainties, you can come out on top. And honestly, just like when you're starting out in poker, maybe not everybody is comfortable with that. Not everybody's comfortable with not knowing whether they'll succeed or fail. And honestly, I don't know how to teach that. I think the best way of learning that is to just go out there and fail. And eventually you realize, though, you can pick up this probabilistic nature to affair. In fact, I think a salesperson would be much more comfortable with that type of uncertainty than an engineer, which is great. And one final thing I would say speed. You need to do quality work, but you have to be fast about it. This isn't like an academic research environment. As a data scientist, you're not going to have the luxury most of the time of thinking 6 months about the project and then maybe getting something done. You have to be fast. You have to be committed to that speed while also doing quality work.
Yeah, you got to be a bit anti-fragile to be a data scientist, right? Something that can thrive and get stronger in the face of uncertainty. So You know what? Let's go and get some questions here from the audience. I'll have Vin answer this first question here because it's for you, and it's coming from Mehdi Rahman. Mehdi wants to know, regarding your comments about looking ahead 1 to 2 years, where do you think the pathway is headed for machine learning engineer roles?
For ML engineering, this is actually an interesting question I've gotten 3 times in about a month now. ML engineering right now is focused on the back end. It's focused on the maintenance phase. And that's going to change. We're actually going to see more of the ML engineering, data engineering roles sort of intersect, because it's the focus on data and on building and curating data sets that almost everyone's talking about now. And that's going to mean ML ops doesn't have to band-aid bad models in production, because that's almost everything that we have in ML ops is sort of back-end focused or source control focused in sort of what source control means to data science and machine learning. And so if you start ignoring the back end of it, you still need some maintenance, but a lot of that's going to be automated. If you look at the platform that enables a new type of development, which is dependent upon clean, quality data sets and intelligent research, intelligent experiments, which create unique data sets. Think about that direction for ML engineering. What would the platform look like to be continuously evaluating the relationship between available data and model quality? So you may not even be gathering that data yet, but you're looking at it and saying, okay, would gathering this data and then using it for this particular model or this project make a better result, make this model more accurate, or allow me to do maybe even some causal inference on a particular system under measurement? And that's where you want to be looking at right now, is the platform that supports your more modern machine learning workflow, and that front end, the kind of the data engineering on maybe 2 years from now, data engineering with a little bit more enlightenment, I guess is the right way to say it, where we look at data as more of an important part of the process in curation, not just gathering, but curation. Right now we gather everything, and we need to start thinking about it as cataloging everything. And that's really where I see ML engineering going, is that front and middle more than the focus right now, which is the end.
This next question I'll field over to Leonard. It's coming here from Arun Ram. Arun wants to know, what would be the future of data science? What's going to be hot or trending in the next 5 years? And is that something you actually think about?
Oh, yes, all the time. And from my standpoint, data science is slightly cyclical, but not completely. Neural networks have been around since forever. Well, since the 80s. And they were mostly ignored until, the right algorithmic developments happened, until the right technological developments happened. All of a sudden they, took off. So it's interesting to think about what else is kind of like percolating close to the ground that hasn't quite taken off yet, but I hear whispers. I see companies start pushing to the space. I begin to use these tools more frequently in my own development work. One area that I think is set to explode is weak supervision. This is where, rather than labeling the, training data yourself, you have a bunch of domain experts come up with like hundreds of business rules and heuristics and simple statistics that are then fed into a process which basically weighs those rules and labels the data for you. Now, the reason that this is a fascinating space is because to couple all the correlations between all the rules and statistics, you need Bayesian thinking. You need to be able to build and run inference on probabilistic graphs. You need to know what a junction tree is. And it's an area of like data science that's mostly been ignored in the recent years outside of the academic space. I think it's poised to make a comeback in conjunction with, again, more popular techniques such as deep learning. And so look for more Bayesian applications cross-coupled with the standard applied machine learning neural network space.
So I got a follow-up question here from Sandra Ruiz, which, Vin, maybe if you can answer this question through the lens of the future of data science. What do you think about auto AI and these technologies that are ready to do all the AI work for us?
That's the nicest response I can come up with. Every time I see auto AI, it just makes me cringe because the problem with auto AI is all the assumptions are hidden. And one of the biggest things that we do as data scientists is iterate through our assumptions and confirm or refute them religiously. Confirm or refute assumptions, and auto AI simply hides them. You throw, you kind of drag and drop, and here's a model, and all the assumptions behind that dragging and dropping, none of that's captured. The basic data that you used for training, maybe it's captured, maybe it isn't. How did you do feature engineering? You probably didn't, or at least not intentionally. How did, all of these things that end up being assumptions that destroy model performance in the long run. Auto AI really has those fundamental problems. And the reason why most businesses have played with it and then thrown it away is because that sort of sits underneath it. Is you run it in production for long enough and it falls apart. And what you're going to see, kind of looking at the future, I see a whole lot of causal inference methodologies sort of being dragged into data science and machine learning. I see way more emphasis on experimental design and research as a front end that produces artifacts that are used across projects, sort of using more of a traditional model development life cycle that relies heavily on those artifacts, those things that are competitive advantages for companies like unique models and unique data sets. And that's really where I see us going, is trying to figure out how do we incorporate causal into the real world, where we have a whole lot more flexibility with causal in the real world than we do in academia. Like some of the stuff we do in business, we get shot twice and burned for trying in the academic setting because it's a far more rigorous standard of proof. But in business, we don't have that same necessity for perfection. And so evidentiary support means something a bit different. And it allows our models to become far more accurate. And I think that's where you see the field going, is trying to figure out how we're going to pull causal methods in to make models accurate, using less data and far fewer resources. And so I'd say if you were looking for a direction that we were going, everything that would sort of support that is really what I would skate towards in your career.
Next question I'll give over to Leonard here. This is coming from Stan Green. Stan says that ageism is a huge issue in most fields. Companies don't want people who are going to retire in just a few years. Is the data science industry better or worse in this regard?
I mean, obviously it varies from organization to organization, and it's something to be cognizant of. Having said that, this is an industry that really values experience. Like, for an individual that has 30 years of solving problems, like not necessarily in the modern data science sense, but like solving, statistics, maybe operations research, hugely ignored area of which I believe operations research is data science, and it's completely ignored from the field. So somebody that has that experience coupled with the new, frameworks and techniques is invaluable. And I do think that in our field, experience, experience is valuable everywhere, but data scientists tend to, all I can really say is data scientists like myself have serious respect for individuals that can bring that experience to the table.
Vin, I saw you had a good facial reaction to that question. So let's hear your thoughts about ageism in data science.
I think ageism is much alive in the data science field in larger sort of traditional big business, legacy business model is what I call them, where a lot of the data science organization is really a repackaging of the software development organization. And so that ageism comes into play, and they have the same biases against experience where they say, well, I can just hire somebody who's 28, they code faster, or they develop models faster, and they cost a lot less. But they miss the important side of machine learning, which has nothing to do with how fast you write code, but how well your model performs. And that's a lot of experience comes into play, and a lot of things that are intangible come into play. Unfortunately, like I said, for the most part, unless you have a very mature data science organization and a very mature leadership structure that is out of, the data science core skill set, ageism still very much a problem.
This next question is from Nazim Ahmed, and I'll answer this question quickly. It's what role will creativity play in the data science world? I think it's huge. Creative problem solving is a huge skill that you can cultivate, and you can cultivate it by reading books such as this one, A Whack on the Side of the Head. So I'm a huge fan of, learning how to be more creative. I talk about this a lot with guests on my podcast. So go check out The Artist of Data Science, type in creativity, and you'll see a bunch of episodes where I talked about that. So let's do one more question here, and it's a question that has to do with transitioning. And Kevin wants to know, is it difficult to transition from accounting, tax, or finance into data analysis? Let's start with Leonard and then Vin, and we'll keep the responses as quick as possible.
It can be done if you put in the work, and most importantly, you have the analytic skills. So get your coding up to speed, and you have got a shot.
Yeah, it's really how far behind the curve you are technically. If you've got the curiosity and you've got the analysis background, and obviously you love numbers, all it is at that point is just catching up to the tools that you need to apply to the problems that you want to solve.
Next question here real quick is, how do you keep your motivation to continue learning and improving your skills? Me personally, I keep the motivation just because I just love learning and I love improving myself in general. So the motivation is just always there. I just always want to be better and always want to learn more and achieve more. How about you guys? Do you guys?
Yeah, I mean, it's for me, I'm fortunate to say that it's an addiction. Like I can't not want to learn. So it happens naturally.
Yeah, for me, I love learning, but I've found throughout my career, I've lost my motivation. And so it's not just important to love learning and, keep that passion going, but to realize that when it dies, you've got to recognize that you haven't been learning, that you haven't been moving forward in your career, and figure out how to reignite that passion for learning. And for me, a lot of the times it means that I'm just bored and I need to change what it is that I'm doing or find new interesting problems to solve. And that's, for me, it's the problems. If I stay focused on problems and value, I stay curious because I have to.
My friends listening at Epic Media, let's do one more question. I know we're going over time, but it's a really important question to ask. And I'll just have Vin respond to this one. What would be, because this question is posed directly to Vin, coming from Chris, it's what would be a good why behind a passion project which doesn't solve a business problem?
Anything that's for the greater good. If you want to do a why behind, poverty is a great thing that you can dive into, because there's a lot of open data sets out there to understand some of the not only impacts but also root causes of poverty, and then use that to model some small solution that supports policy. That's excellent. Anything that you could do to support policy decisions, even better than business problems.
Leonard?
Yes. Honestly, I want to keep it even more general than that. Anything that I value curiosity. A passion project is just that. It's an emphasis of your passion. I mean, poverty is great. Social value is great. But anything that shows off your ability to be creative and artistic, from my standpoint, is a beautiful project to carry forth with.
Yeah, I think in general, if you want to succeed at data science, it needs to be coming from a place where everything that you do feels like play to you, but it looks like work to everybody else, right? Because us sitting here, heads in the books, writing things out, coding, it all looks like work to other people. But when I'm doing it, it feels like play to me, and it feels like I'm having a good time. And if you adopt that mentality that, okay, what I'm doing, other people think it's work, but to me it's fun, this is play, I enjoy doing it. You take that attitude, I think you will be able to successfully transition into data science. You'll be able to successfully excel and get to the highest levels in this field. My friends, thank you so much for joining us for this panel discussion. Do me a favor right now, take a screenshot, tag me, tag Leonard, tag Vin, use the hashtag DataScienceGoVirtual, post it on all of your favorite social media sites. You guys know that we're giving out awesome prizes, so make sure you do that. Leonard, Vin, gentlemen, thank you so much for taking time out of your schedule to come onto the panel discussion. I know that the audience absolutely loved this presentation because I did. And to everybody out there that we didn't get to for your questions, my humble apologies. Maybe next time we can get to them.